Here we'll access online NOAA tidal data, bring it into Matlab, and plot it. Let's find the NOAA tides and currents site, and then click on Connecticut, and I'll select the New London station. I'll go to the station home, and then under tides and water levels, let's look at water levels. It shows the time series of both the predicted and observed tides. The predicted is blue, and the observed is red. Let's change the time period from January 1st to January 10th. And I can change the units from English to metric, the time zone to LST/LDT, local standard time/local daylight time, and the vertical datum to mean sea level. And we can update the plot. Let's look at the data listing. The data are at a 6-minute interval. There's the predicted column and also the preliminary observation column. Now let's export to CSV. That file is downloaded, and so it'll open up in Excel. You can see the date, the time, and then the predicted and preliminary data. I'm making a new column here, and it's going to be a new time column that's easier for Matlab to deal with. I'll start with time of 0, and then I'll add on for every next entry an extra 6 minutes. And we can check that just to make sure there are no gaps causing problems. Still looks aligned, so we're good. Now I'll label that column, make it bigger, and then we're going to select these 3 columns, the new time and then the predicted and preliminary, to bring into Matlab. So I'm just going to copy that in. And go to Matlab, establish a variable dat, open brackets, and then paste the data in. Takes a while to load, but there it is. It's 2,400 by 3. So time is the first column. I'll establish that as a new variable. Predicted is the middle column. And I'll make a variable preliminary for the observations. That's the third column. I can clear the dat variable. I don't really need it anymore, and it is taking up memory. And then I can save these data to a Matlab data file. The next step is opening up a figure, making sure it's clear, and then plotting the data. I'll plot the predicted first. I'll plot it in blue like the NOAA website has it. Turn the grid on and hold it, and then I'll plot the preliminary in red. We can put in an X label and also a Y label in the title too. Let's look at the figure. Looks good, but let's stretch that out to make it look more like what's on the website. So I'm just stretching the figure window. But now that y-axis label is too long, so I'm just going to click on it and shorten it up. So I'm editing the figure itself. And I'll stretch it to get it about the same length and aspect ratio. That looks like a good match. Matlab has a day convention. For instance, the 1st of January 2022 is 738522. We can make a new variable, Matlab days, and just say time plus 738522. That's one way to write it. Or I could say Matlab days plus my starting time, which is the 1st of January 2022. Now I'm going to make a new figure that's going to be very much like the other figure. It's just that I'm going to use Matlab days instead of time as my independent variable. Now let's look at the figure. You see the numbers are confusing on the x-axis, but we can use the Matlab function dateTick to make this look better. And now you can see that month-day format on the x-axis. And this procedure should work for plotting all Tidal data, and many other time series too.